Hey guys, this is our last little topic for today. I just wanted to check in with you about one little piece with KW that we probably could have gotten back when we went over that with the autoionization of water, but this is just where it kind of came up. And it has to do with the temperature dependence of KW and also specifically having to do with the pH of water when it's not at 25 degrees Celsius. We've seen this show up in some multiple choice questions. So one thing that we did talk about when we did the neutralization reaction is I had mentioned that neutralization reaction has a constant overall heat of reaction, so that when the proton or hydrogen ion from an acid reacts with the hydroxide from the base to make water, it releases about 55 kilojoules. So which makes sense, you're forming water, so we're going to have an exothermic reaction. So when we talk about the self or autoionization of water, here we're just going to show it in terms of hydronium and hydroxide. We have our two waters. This is going to be an endothermic process. It's going to have to absorb energy in order to create the hydronium and hydroxide. At 25 degrees Celsius, the Kw we know is 1 times 10 to the negative 14th, and the pH is 7. Because of the fact that the concentration, I'm sorry, this is in yellow, hold on, I can't see that. The concentration of hydronium, if you remember from last week, is equal to 1 times 10 to the negative 7. So that's where that's coming from. So then if we look down here and thinking back with equilibrium and Le Chatelier's principle, if we take that equation and temperatures increase, it's going to favor the endothermic reaction. So we're going to see this shift in this case towards the products, which means the amount of hydronium and hydroxide is both going to increase. Now, if we think about our expressions, Kw is going to increase as a result of that temperature going up because of the product of two higher values. That also then is going to cause, because there's more hydronium, okay, is going to cause the pH to actually decrease and be less than 7. And depending on what the temperature, you get something like 6.8 or something like that for the pH. So when temperatures increase and it shifts to the right to favor the endothermic reaction, there will be more hydronium and hydroxide. Technically, those amounts are equivalent to each other, but because there's more hydronium present and looking at pH, our pH is actually going to go down. Now, obviously, the opposite is going to be true if our temperatures increase. So again, temperature increase, our pH is actually going to decrease. However, when we have our temperature that is decreasing in this case, it's going to favor the exothermic reaction. So in this case, it's going to shift to the left to reestablish equilibrium, which will cause the concentration of hydronium and hydroxide to decrease in this case. And keeping with the same equations from before, the Kw is going to decrease because the product of those two smaller values, and because there's less hydronium in solution, the pH will actually increase, something like 7.2. So just like a little fact to think through now, because again, when you have a minute and a half per question, it's not something that you might be able to do as easily. So if you kind of have seen it ahead of time, it helps. All right, so just kind of keep that in your arsenal in terms of some little topics throughout this unit that we're going to see.